Hello, Shoyan here. Today, I'm working on the ceiling. These two existing 3.6-meter beams have sagged a bit over time. So I start by installing exposed support beams underneath, then move on to the ceiling. I start by prepping the support beams. When planing an exposed support beam like this, it's important to choose the right face of the timber. I want the clean side without knots to be facing down. When installing timber, it's also key to think about which way it's going to warp. It should warp upward. If it bows downward, it defeats the purpose. This timber has been drying for over 3 years. Once it's that dry, the grain and warp become more noticeable, which actually helps. Back in the day, we used green wood straight from the mountain. We'd saw, mark, and cut it while it was still wet, and by the time we used it, it had dried out. So we had to predict how it would warp right from the start. Timber was harder to get back then. These days, with properly dried wood, it's much easier to read. We call this ategi in Japanese. It's a type of wood that tends to warp. This piece has a warp that runs across the grain, and I'm installing it according to that warp. It's very challenging to read wood perfectly, even for experienced carpenters. I plane the bottom edge to be more concave than the original warp. That way, even if it sags 3 mm from snow away, a 5 mm upward curve keeps it from looking droopy. I'll cut the support beams to length on site, then finish them with a hand plane afterward. 2 of us carry it, but a 300 mm pine beam weighs nearly 100 kilograms.
Hey, no.
We somehow managed to get them inside. Now I start installing the beams. I can't do anything fancy here, so I keep it simple. I notch the column 15 mm and slide the beam in from the side. Then I secure hardware on top to set the beam. That's how it'll be installed. Only the bottom 15 centimeters of the support beam is visible. The ceiling goes up from there another 15 centimeters. So, the new ceiling ends up being 15 centimeters lower than its original height of 2,650 millimeters. This house uses thick, full-height cedar columns. I heard the wood came from the homeowner's mountain. Even cedar hardens a lot over 50 years. The knots become rock solid. With knots like these, you can crush the edges by tapping them with a hammer. I try to get the length just right with no excess. Even if it's only 1 or 2 millimeters too long, it will be impossible to install. So I cut it 1 millimeter short. Now I mark the cut lines. I gave the top a slight upward curve and the bottom an inward one. So as a reference, I snap a level line first, then draw vertical lines at right angles from that leveled line. Now that it's cut to length, I do the finishing work. It's tough to transport finished beams from the workshop without leaving marks. Even a circular saw cut can scratch the surface. It's extra work to hand plane again, so I do all the final finishing on site. This is on November 22nd, Good Couple Day in Japan. I got an unexpected invitation to appear on a live radio show. It turns out this day is also Carpenter Day, as designated by the guild. I doubt I got the invitation for the couple's theme. It must have been for Carpenter Day. I talk a bit on the radio. It's quite a day.
そうですか。ありがとうございます。せーの。よいしょ。せーの。よいしょ。
Now we install the support beams. 4 of us lift each one by hand. We shoulder it, raise it up, and 2 of us slot it in at each end. It feels like only 2 people are holding it, but all 4 of us are working together. If either side slips, we're all going down. Pretty risky.
もう入ったの？入ったんか？もう入ったの？オッケー。せーの。よっ。はい。よっしゃ入った。よっしゃ入った。そっち応援行こうか？入った入った。
We somehow managed to get it in. Even a 1mm misfit would have messed everything up. I fasten it with a few screws. There's no specific hardware for this, so I use a strong plate with lots of screw holes for seismic safety. The beam above is joined with a long tenon and pulled tight with a bolt. That locks the column in place and keeps the support beam secure. Still, I add the plate just to be safe. In the middle of the 3.6 meter span, I install a single post, cutting it slightly long to ensure a tight fit. Without this, the beam above would keep sagging. This helps spread the load from the top beam and support beams so that the beams won't sag further. With the support beam set, I move on to the ceiling. Before framing, I install stud-like lumber around the bay window. There's no place to secure the ceiling frame above the 1.8 meter lintel. Either 600mm or 900mm intervals would be fine, but I'll frame the wall at 900mm this time to secure the ceiling frame firmly. The ceiling frame is the usual 39mm square lumber I always use. Ceiling renovations aren't all that different from new construction. Floors and walls usually need full rebuilds, but for ceilings, you can use the leveled floor as a reference and frame the perimeter of the ceiling if needed. If there's no existing structure, it's pretty much like framing a new house. This ceiling has the support beam running right through the center of the 3.6 meter span, so each side is 1.8 meters. Since each side isn't very long, I only gave each section a 3 to 4 millimeter upward curve, just enough. I also retighten all the bolts as firmly as possible where I can. Standard ones, Hagoita bolts, and bolts for angle braces. Ideally, the ceiling would be under the second floor, but some of it is under a lower tiled roof. Old houses like this have exposed rafters and eave closures. These gaps let wind into the attic. Some people say this is good for ventilation, but direct wind hitting ceiling boards isn't great. Even laying down a bit of insulation helps a lot. It's like adding a blanket, simple but effective. This isn't full-on insulation work, but it does the job. Now, I finally installed the ceiling boards. I always need my trusty assistant here. I can't hold the board up and screw it in at the same time. This ceiling won't be finished with wallpaper. It's getting plaster. So I glue all the joints to prevent cracks, especially since the frame only runs in a longitudinal direction. Now, the support beams are in and the ceiling boards are up. We had a little hiccup and the usual closing shot got lost, so I'm wrapping things up here with my voiceover. The ceiling is complete. That's all for today. Thanks for watching.